Good day, folks. In this one, we're going to be importing an enemy and scripting him. So let's go ahead and check that out. First of all, the asset we're going to use for this one I have attached to the Dropbox, to the forum. So just click on download image after you've clicked on him, and then just put that wherever you put all of your fun downloads. From there, it's Unity time. Okay, so we're going to be going and importing him into the characters folder under sprites. And assets, art, sprites, and characters. Let's go ahead and just do a right click, and then we say import new asset. My bot.png is on my desktop. Yours might be somewhere else. So go ahead and let's import that. Okay. From here, let's go ahead and drag it to the hierarchy. And let's just call this, rename this, I don't want to duplicate. No. I want it to rename. All right, so let's call this robot, a robot. Now, I've been trying to figure out why so I'm going in here in the import settings, looking at the dimensions of this. It's 256 by 256. In the official instructions, it says that should be 120 pixels per unit. I'm not 100% on why that number is what it is, but let's just go with it for now. Okay, so where it says pixels per unit for this, set this to 120. Okay, we'll go to apply that. Just resize this window. Good. Okay, so we applied that. Great. So now we got to go to this robot, and right now this robot's way over here. Let's move it over to right here. Okay. What we're going to do now is we're going to add a lot of the components that we added to Ruby. So we're going to add a rigid body 2D and a box collider. With the box collider, we want to just go ahead and refine this a little bit. So let's change that box collider to I don't know. What are you doing, man? Change this to, just kind of like his feet, the bottom portion of him. That's just fine. No right answer with this. The other thing we're going to do is with our rigid body 2D, our physics system, we're going to turn off gravity. It's just that easy. And then we're going to go ahead and do freeze rotation on the Z. We did all these things with Ruby. A lot of what we're going to be doing in this lesson will be sort of riffs off of what we learned to do with Ruby. Okay? So we go ahead, might be some other adjustments later, but for now that's good. Okay, well, we've got a robot, we've got a game object, great. What's next? Let's go ahead to our scripts folder, do a right click, create C# script. We're going to call this enemy controller. Okay, capital E, capital C. Let's open it up in VS Code. Hopefully you have at this point. If you're comfortable using Notepad, you can use that, but why? Syntax highlighting is so nice. Let's go ahead full screen here. Okay, a lot of what we're going to be doing is going to be based upon what Ruby showed us as far as some of the basics. I'm just going to dismiss this stuff. So let's start off. We're gonna declare a number of variables here. So I'm just going to be doing some copy and pasting. So it's going to be within the enemy controller script. So we're going to go ahead and we're going to do two variables to start. Public float speed, and that's going to refer to speed. Since it's public, it's going to be accessible via Unity's editor, as well as if we want to have something else kind of hook into it. So if you wanted something to change the enemy's speed, you could have that happen. Now this Boolean of vertical, this is going to be related to are we going to have this enemy go sort of up or down? Up and down or side to side. A Boolean variable is going to be related to, remember we saw a Boolean when it came to is invulnerable with Ruby. A Boolean is going to be either true or false. And since it's public, this will be something that we can just change in the editor. Okay, next one, change time. So we have, and this will be something that's also public. We want to have it so that this will be kind of not really a constant, but it'll be something that we can easily change in the Unity editor that's going to basically set it up so how long do we want to go up and down. So if we think of a kind of a robot enemy, kind of at an origin point of 0, 0, on a plane, do we want him to go up for 3 seconds and then down for 3 seconds? Sort of like that. Like how long do you want him to patrol on a certain path before they turn around? Because we don't want him just to like run off the map. Okay, other things. This is going to be something that should be familiar. We're going to declare a variable called rigidbody2D that's going to allow us to hook into the physics component. And then we're going to go here to our 2 more things. Timer and direction. Now timer is going to be related to kind of, again, as it sort of implies, the timer variable is going to like tick, 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 tick down, and that's going to be related to our change time. But our timer is going to be what allows us to calculate how long we're going in one direction versus the other. Direction is going to be related to that as well, as far as like, are we going, which way or the other. All right, now, 2 things we're going to add here on when we sort of start our program. This line 19 here, at least for me, this rigid body component, this is something we saw with Ruby. This is how we hook into the physics system. Timer is going to be at least started, given the initial value that we assign to it. Sorry about that. No, sorry. This timer is going to be given the initial value of 3 seconds, or 3.0, and then we're going to have that start off with the value of 3. Now, update. This is the fun part. I'm just going to paste this from like repurpose my code. All right, so this is going to be update. I'll start off here. Timer, so this is going to be every frame. Timer minus equals time.delta time. This is called an extended assignment operator. I believe we've discussed before. But what they're going to do is we're going to take whatever timer is currently at and subtract whatever time.delta time is. So this is going to be something like how, remember, we're using update and delta time. This is going to be so that no matter what the kind of type of hardware you have, it's going to be a smooth experience. And so this is going to what's called decrement the timer, or reduce the timer over every like sort of up frame update. Now, this is an if statement. If timer is less than 0, reverse the direction. So we said before up here, direction is going to be set to 1. That's positive 1 right there. So we're going to say here, once the timer ticks below 0, we're going to say, set whatever the direction is, make it negative. So the first time this if statement is executed, the direction will be set to -1. All right? The next time it goes through, it'll be set to -1. A negative of a negative is a positive. So this is going to be how we kind of alternate between positive and negative directions. Okay, timer equals change time. This will basically be like, okay, once you've now, once the timer has run out, go ahead and refill. It's sort of like, think of an hourglass. This is the filling of the other side of that hourglass. Okay, I'm going to just make sure I've got the right number of brackets. Update is with that. That's good with that. And then finally, we've got a paired with this. I don't know if I have enough updates. I'm going to just pause it a second and make sure I've got what I need, okay? Yeah, I'm good. I had to re-record this lesson, so I just wanted to pause a second. Okay. All right, so update is done. Now we're going to go ahead and add our fixed update, which is what we had used with Ruby to get to hook into that physics engine, rather than having it work through the whatchamacallit, through the game object mover. Okay, so I'm going to just paste this in, and we're going to go through the different lines. Make sure it's after update. Okay, so void fixed update. So this is right after that last bracket for update. Fixed update, this is here we declare a vector2 variable called position. And remember, the vector2s, as it sort of implies, vector2 variables have an x and a y, that you can hook into. And that is based upon whatever the physics engine currently sees as a position. So remember that Boolean we had up there, if vertical, change the positions y by, whoops, I didn't mean to do that. Change the y by time delta multiplied by speed and multiplied by direction. So this is what's going to move the character. Either, in this case here, if the vertical Boolean is set to true, it's going to move vertically. Otherwise, change the X position. And then regardless of if you change the X or the Y, then move it. Okay, let's save our work and let's go into Unity. Good. All right, so this warning you can ignore. This is fine. Let's go to Robot. And then let's go ahead to our enemy controller and click and drag it to our robot. We're going to see a few things. Now we have an enemy controller. We've got speed set to 0, a vertical flag not flagged, and change time set to 3. All right, let's see. Let's first of all change the speed just to 1. And let's see what happens. So you see it's going to move to the right, then back, the left. So if we see here in terms of, I guess we could do like a debugger to print out like the timers and things like that, but no need to. The other thing we could do though is if we set the flag to vertical, what do you think is going to happen? I know what's going to happen. It's going to move vertically because that Boolean, if we go back to our code, in the second case, the second time we ran it, this vertical Boolean here was set to true. So that means that that code would execute. Okay. I think that's it for this one, folks. I wish you the best of luck. Great stuff.